In this video, we are going to look at the chemical reaction lab, and it's part one, the classroom demonstrations. So if you didn't go to class, or if you saw the class and wanted to see these videos a little bit more closely, you can watch here and kind of get it so you can see things right here. And let's see. So first thing we have is zinc plus hydrochloric acid. This is hydrochloric acid. It's a clear solution. However, it's 6M, which is 6 moles per liter hydrochloric acid, which is really highly concentrated hydrochloric acid. And this other reactant is just a piece of zinc metal. And I'm going to drop this in here. And let's see, I'll kind of hold this out so you can see it and drop this in. And I don't know if you can see that, but there's definitely bubbling and fizzing. I'm going to take another container and put that over the top of this. And I'm going to grab the clamp to do that. It's quite vigorously bubbling at this point. And let's see, I'm going to grab a wood splint and a lighter. Having trouble doing that with my left hand. I'm going to do this and I'm going to light that right here. Okay, it does help to have a lab partner, but I don't have that. Try not to put my hand in the flame. So I'm collecting this hydrogen gas, which is less dense than the air, so I'll keep it turned over. Then I put this flame in here, and we get a little popping sound right there. And that is an indicator of hydrogen gas when it pops with a burning splint. Okay, we'll turn that out. Hydrogen, what the zinc does replace the hydrogen and hydrochloric acid because it's higher up on the activity series than the hydrogen. So it's more likely to lose electrons, and that's what happens during this reaction with zinc plus hydrochloric acid. Next one is going to be a double displacement reaction. And I'm going to slide this over here, move this in the forefront, get rid of a couple of these things. And this is reaction 2. It's double displacement. There's a clear fluid on the bottom, and that is sodium iodide, I believe. And we have another clear solution in this test tube, which is about half full, and that is lead nitrate. So there's going to be a double displacement reaction going on here. I'm just going to grab this balance here and I'll weigh this before and after. So, zero the scale, ready to go. So this whole system weighs 109.61 grams. Okay, 109.61. What I'm going to do is flip this over, and these two things are going to intermix. And notice it gets that bright yellow color. Okay, I'm looking at the mass. It is still 109.61 grams. So even though these things mix and the reactants turned into products, you have the same atoms at the beginning, same atoms at the end, so you have a conservation of mass. And that's the whole principle behind balancing equations, that you have the same atoms on each side. So if you have the same atoms on each side, you should have the same mass on each side, and you do. This solid that form is called a precipitate. If you let it settle out, you would be a solid that formed at the bottom when you combine two solutions, which is a precipitate. Okay, and that would be the lead iodide in this case. Lead-based paints are really, really bright colors. You can see this kind of brilliant yellow. However, lead-based paints, if you adjust the paints or things like that, that can be an issue. Okay, the next reaction is going to be a synthesis reaction. So we're going to come over here, and I have a Bunsen burner. And I'm sorry, yeah, this will be a synthesis reaction. I think you can see that there. I'm going to turn the gas on. I'm going to light it. Okay, so you get a flame. Oh, that's a pretty good flame right there. And then what I'm going to do is I'm going to take a strip of magnesium. I'm here, just tightening a little bit. And I am going to, don't look directly at this, look a little bit to the right or a little bit to the left. but I'm going to take magnesium and combine it with oxygen to form magnesium oxide. Okay, so get that. So I'm not looking directly at it, but getting this reaction here. So we had that magnesium metal combined with oxygen in the air, and there's a little powder that we're creating right here, and that is the, I don't know if you can see that there, but that is the magnesium oxide. That's down here, a little bit of unreacted magnesium too. Okay, and let's see, another reaction we have. I'm gonna have to move my computer for this. This is a decomposition reaction where I take hydrogen peroxide and water. I have this here. Let's make sure this is lined up pretty good. I have 30% hydrogen peroxide. You get 3% in the store, so this is pretty strong stuff. And I have some dishwashing soap. I'm using some, I could use Dove. I'm using Dawn today. I put a little bit on top here. And then what I'm going to do is I'm going to take, now the hydrogen peroxide will break down on its own, but it's really, really slow. So I'm going to try to speed that up by adding a catalyst, which will speed up the reaction. So here we go. The catalyst in this one that we have, I think is what, sodium iodide. So I'm going to throw this in here and let's see what happens. Whoa, look at the steam being generated. Make sure this doesn't attack my computer too much. Okay, keep it a good distance from there. And it is getting warm. When it gets warm, that is an exothermic reaction. It's the reaction itself is releasing energy to the surroundings. My hands are part of the surroundings, so they're going to feel warmer in this type of reaction. So this would be a decomposition, and it's assisted by a catalyst, but it's breaking the hydrogen peroxide into water and into oxygen gas, which we could test with a burning or with a glowing split. It might relight on fire to do that. Okay, the last reaction that we have, we're going to go back here. We've actually seen this one, is a combustion reaction. And this would just be lighting the Bunsen burner here. You're taking a hydrocarbon, which would be methane or CH4, binding with oxygen. The main two products are CO2 and H2O. And yes, it does feel warmer. So you should be able to know what type of reaction that is. So those are reactions 1 through 5 for your lab. There'll be another video with reactions 6 through 10. And then you can write the equations for these reactions and answer the bullet points as you do this lab. Thank you.